So on the lecture we are going to have finding inverse of square matrix. So A is given. We want to find A inverse. What's the property? The property is that when you multiply with the original in any order, you are going to get identity. The style that we are going to use is based on elementary operation. We said we take a matrix and then we are going to apply a sequence of elementary operations to it. Elementary operations are either exchange of rows, multiplying a row by a number, or adding a multiple of a row to another row. So we judiciously choose these things and apply them. So we might have some operation, let's call it operation number 1. It could be any of these 3 operations. We carry that out, then we carry another one, and then we carry another one. So we do a bunch of these things, as many as it takes, until the matrix, after all that manipulation, is reduced to identity. Let's assume that it happens, that actually it does reduce to identity and no obstacles show up. If it so happens, then these operations themselves have to be playing the role of A inverse, that the accumulation of all of these things together is the same as the inverse of the original matrix. So if I take all of these things and apply them to identity, I'm going to get the inverse of the given matrix. Let's see how this thing is going to be carried out. Take an example from the text. It says find inverse of a matrix that is given to us as 2, 1, 0, minus 4, minus 1, minus 3, 3, 1, 2. So that is the original matrix that we are given. So again, we keep in mind that we are going to perform a sequence of these activities. Later on, well, each of these activities are done one at a time. At some stage, we actually need to find the product of all of these things, the cumulative effect of the whole thing. So we are going to have a kind of a column or a running total for the net effect of the product of these. So the way we carry it out is that we augment this matrix. So we take this matrix 2, 1, 0, minus 4, minus 1, minus 3, 3, 1, 2. We have this matrix. Next to that, I put the identity matrix. This one is going to help us to carry all these multiplications. We are going to apply it to this identity one by one, and after a long march, this column is going to lead to inverse, while this one is going to lead to identity. So general objective is apply elementary operations to the entire augmented matrix. So A is on the left and I is on the right until, so after a sequence of operation that we apply, this is going to become identity, and this one, when we apply exact same operation to this one, this is going to be reduced to inverse of the original matrix. Typically, it's a lengthy process, has to be done carefully, double check every stage, use good judgment on how to carry it out, and then you'll be all set. Okay, now let's go ahead and do that. So I'll remember that we are trying to reach this form. That is, there will be ones on the diagonals and zeros elsewhere. Now there are always many choices that you have as to which one of these operations to carry out first. Remember, we have 3 elementary operations. We have either the exchange or multiply a row, or add multiple of a row to another row. We use them to create this particular look. How you do it? Well, you have many choices. We are going to talk about 2. One choice is what you do by hand on a small matrices which are made out of whole numbers and such. That's one strategy that is used. And then when you want to actually do it on a computer, or you want to run a program to do it, somewhat different approach is used when you are not afraid of handling decimal numbers and such, or your data is actual realistic data and these are not always it's kind of nice numbers. You use that alternate approach. Okay, now for our first step, you can go ahead the way we have been doing at the beginning of the semester. At the beginning of the semester, we were trying to get echelon form. Echelon form was trying to get rid of these entries and converting them into zeros. So it would have created this look. Essentially, we are going to duplicate the same procedure. Whatever we were doing there, we are going to just do here as well. It's just that we are going to add 2 other stages too. After we are done with these, creating these zeros, we might go ahead and also create these zeros. Now, there are different styles. Some people create these green zeros as well as these yellow zeros at all at the same time. Some people do all of these things first and then do those later on. Either way, that's fine. In the echelon form, we were not insisting that these numbers have to be 1. They could have been any number. So when you apply those ideas of echelon form, you might end up with something other than a 1 here. That's perfectly fine. You can always come at the very end and multiply a row by a number until it becomes just 1. What you probably need to pay attention to is that when you are doing hand calculation, you want to avoid fractions as much as you can. So that becomes the only essential point here to pay attention to, that you want to make sure you don't unnecessarily create fractions early on, and try to push that task as far out as you can so that you don't have to deal with that error-prone situation. Okay, with all that advice in mind, let's see what can we do to, say, get rid of this entry. So we can apply twice row 1 and add it to row 2, and that is so how did we say we write this? We say 2R1 plus R2 is going to be our new R2. The only thing that you need to pay attention to is that you have to do it to the entire augmented matrix, because we said these operations that you are applying, you want to apply them to identity as well, so that the accumulated effect of all of them is going to create the A inverse for you. So it isn't just this red one, but also you apply it to this green one on this side. So let's go ahead and do it. While we are doing it, of course, for now, the entries there don't change. So I double this and add to that, so I get my zeros. This 0 I want to create, I did it. 2 times 1 plus minus 1, what do I get? A 1, is that right? Twice 0 and minus 3, this is still minus 3. Twice 1 and that, so that's going to be 2. And the other entries don't make a difference right now. Now, since we are going to be doing a lot of writing here, we might as well do all the processes on this matrix that we can, all at the same time, so that we don't rewrite same lines over and over again. So what does that mean? It means handle all the elements of this column at the same time. So here, we go aim for 3. What should I do to get rid of 3? Okay, we said twice row 1. So this was 1 0 0. We double it to 2 0 0. Add it to the second row, and so we created 2. Okay. So yeah, it's important to keep doing everything to all of this augmented matrix, not just that one. Our next stage, to get rid of this 3, we had a procedure of making it automatic. We take that row, divide by its pivot, multiply by the number you want to get rid of, and multiply by minus. That means you take row 1. First you reduce this into 1, so that means divide by 2. Then you multiply by the entry you want to get rid of, 3. And to get rid of it, you have to multiply by minus. Plus row 3 goes to row 3. This is called the multiplier. We are going to have more chances of coming across this actually important number. Let's check again what happened. So this one, this is your pivot. The pivot number that you had here. So when you divide that row by the pivot, that makes that entry to be 1. When you multiply by this number, you are creating exact same quantity in that location. Since you want to get rid of this, you have to subtract. So this is the number to eliminate. And that minus is the act of your subtraction that you are doing, or elimination that you are doing. So let's do that. What do we get? Minus 3/2 of 2 is minus 3, and you add that to 3, you get 0. Minus 3/2 times 1 plus 1. What is that? Negative 1/2, is that right? Minus 3/2 of 0 and a 2, well, that is just a 2. Tell me what happens here. Negative 3/2 is a negative 3/2. That is not changed. That is not changed.
Would this be considered one operation, or is that two separate?
These are 2 operations, but as we said, we write them in one round because we don't like to write these matrices over and over again. So everything that applies to a column, or at least to these entries, you want to do it now. That would be to your advantage. Okay. Now remember, for echelon formation, we were insisting on to get rid of this entry. Now we are adding a new requirement that not only this entry we want to get rid of, but also that entry. We want to get rid of that also. Okay. Who is our pivot? Our pivot is this one. That is the entry that's going to guide us how to get rid of everybody else on that column. Right now there is no reason to exchange, so that guy, we are not using that operation. So let's so to get rid of this entry, what do we do? Just twice, what do you say? Twice R2 plus R3 is going to be our new R3. So that row is left untouched now. Excuse me. Yes. How do what? I'm not paying attention. Let's try again. Okay, you were correcting me. What should I write here? 1/2. So R2 is our essentially pivot row. This is left untouched. So this is row 2. The whole row is going to stay put. Now there are two styles. If you want to work below, every row above that is also left untouched. Let's just go ahead and do it. Let's see what happens. 0, half of this and that one, what do I get? 0. Half of 3 and a 2, I get 1/2. Half of 2 and minus 3/2. So yes, half of 2 will be 1. With this one is going to be minus 1/2. Half of 1 and add it to this, I'll get 1/2. And here, just 1, because half of 0 is just 0 with this. Now, again, you have two options. Keep going like this and then come back and take care of elements above it, or you might choose to get rid of this entry also. Okay, so let's do it like that, handling an entire column at the same time. Now this one you hadn't seen in echelon form, because in echelon form we were just handling the lower section, and the upper numbers we were delegating it to the back substitution stage. Essentially, when you get rid of this entry here, you are performing the back substitution here as well. So back substitution and former elimination are being done at the same time. So again, that's just your choice. Now, how do I get rid of this guy? Okay, so we always take a multiple of our current row. So here's my row 2. What multiple of it should I add to row 1? Negative R2 plus row 1 is going to give us new R1. Notice this entry stays as 2. What do I have here? 0 as we intended. What do I have here? 3. What do I get here? Negative 1 here. Negative 1, 0. Is that right? Say that again.
On row 1, column 1, that 2, is that supposed to be a 1 because we're adding a negative 1 to it? Or is it just to that pivot point?
You're talking about this 2?
Yes, sir.
Okay. Negative of this row is added to that, so that 2 is not touched. Once, yeah, okay. Here, let's see, what did we do here? We came from 1/2 of row 2, we added to row 3, so minus 3/2 and a 2, we got 1/2. Okay. So once again, this green row, you could have done it later, or you could have done it now. Now, who is our next target? Yeah, these entries, those are again elements that you would have taken care of them in the back substitution stage, but now that's all that is left. We are using this as a pivot. it is to our advantage to make this our life as easy as possible by making this into a whole number if we can. Eventually we have to make it a 1 anyway. So what kind of a strategy would you suggest so that we clean this up a little bit? You said what? Yeah, 2 times row what? Row 3. So here is a use of that multiplication. So we just take this row, multiply it by 2, because it's a lot easier to work with a 1 here than anything else. And second, this has to become 1 anyway, so you might as well go ahead and do it. Well, it has a cost of rewriting all of this thing. Yeah, rewriting itself is a problem. So here's the 1. What do I have here? Negative 1 and 1 and, say it again, 2. Is that right? So there, it's nice that this is a 1. What's so great about it? Because when you want to use the pivot, life becomes a lot easier. So who is our pivot? This is our pivot, and we go ahead and say, okay, to get rid of this entry, what do I need? 3R3 plus R2 is our new R2. And then same business here. What do you do here? Minus 3R3, of course, plus R1 is R1. So let's go ahead and carry this out. So 0, 0, 1, minus 1, 1, 2. Let's do that one. So I get 2, 0. What do I have here now? 0. And then what is the entry in this location? 2, is that right? Minus 3 times minus 1 is 3, and minus 1 makes it 2. What about this location? Minus 3 times that makes minus 3, and minus 1 makes minus 4. This entry, negative 6. Because minus 3 times that entry plus that entry is a 6. Now, for influencing the second row, this is 0, this is 1, this one will be 0. So 3 times minus 1 and a 2, I get a total of negative 1. Here, 4, and here, 6. What is left to do? Yeah, row 1, we want to make this identity, so we have to multiply by a 1. So I get 1, 0, 0. That makes this into 1 minus 2 minus 3. Then 0, 1, 0 minus 1, 4, 6, 0, 0, 1, minus 1, 1, 2. So our strategy again was like this. On the left, we are manipulating the matrix until it becomes identity. If we arrive at this stage, the right column is going to arrive at the inverse. This is the inverse. If the process breaks, that at some stage we see we cannot progress anymore, that would be an indication that our original matrix doesn't have an inverse, and the process is going to be terminated in a failure, indicating that what we are looking for doesn't exist. Okay, once you get to this stage, what is it that you need to do? You need to do at least some checking. So let's do, how do you check? Yeah, 1, 2, minus 3, minus 1, 4, 6, minus 1, 1, 2. Our original was 2, 1, 0, minus 4, minus 1, minus 3, 3, 1, 2. So how do we perform a check? Just multiply. Yeah. Multiply this. with all these columns, at least a few of them, as much as time you got, you can just check it out. So let's see, what do we get? 2 minus 1 0. What's the net? 1. 2 1 0 times minus 2 4 1. So we get minus 4 and a 4 and a 0, so that it is luckily 0. Minus 6 and a 6 and a 0, that is 0. Then we just repeat the process with each of these rows. So minus 4 1 3. So what do I have? Minus 4 plus 1. So far I have minus 3 plus 3, I make a 0. Let's multiply with the second column. I have minus 8 minus 4, plus 8 minus 4 minus 3. So what's the total? 1. Last row I have plus 12 minus 6 minus 6. So I get a 0. Last one, 3 1 2 times 1 minus 1 minus 1, 3 minus 1 minus 2 as required. Minus 6 plus 4 plus 2 is 0. Minus 9 plus 6 plus 4. That's 10 and minus 9. Once it works out one direction, it has to work out in the opposite direction as well. That is, you wouldn't, if you have done this incorrectly, you don't need to check it the other way around with that times this one. At any rate, so this was our original A, this is our A inverse. So once our checking is complete, we say we found the A inverse, and that is 1 minus 2 minus 3 minus 1 4 6 minus 1 1 2. Now it is quite rare that the answer comes out to be so nice with all entries being whole numbers and such. It's a super rare situation, but many problems you encounter are kind of like this, or slightly more complicated with a few fractions here and there. In real life, these are all entries are decimal numbers, and the process becomes actually laborious by the time you want to get to the bottom, and issues come up as to the so-called round-off error. When you are doing decimal calculation, there are always some digits that you cut off. You keep 2 digits, 3 digits, and so on. A very significant issue comes up. So how safe is that? If you keep cutting digits, what happens in many mathematical calculations is that those digits that you cut off, they tend to snowball, and your errors compound, and at the very end you can end up with something that you believe to be an inverse, but perhaps has nothing to do with the inverse. Just because you kept cutting off those digits, you end up with something that is not really the true inverse. So those issues we might come up and talk about them later. So that is one exercise. Now let's take a look at some situations where the process fails. So if the process how can it fail? You remember on the left column you are trying to create an identity. And the only operations you are allowed are those elementary operations. Sometimes there is no operation you can apply that will give you an identity. For example, so if the process fails, A inverse does not exist. We said there is a whole slew of matrices which are not so obvious, that don't have an inverse. So some cases quite obvious, like if I have a matrix with everything 0 on it. Let's take a 2 by 2 matrix. Suppose this is my matrix, and I ask you find A inverse. This is a bit overly simplified, but suppose I want to proceed. Well, what is the objective of this process. The objective is to make this thing into identity. Is that right? Objective is to create ones in these locations. But is there anything I can do to create a 1 here? Well, if I exchange, it's still a 0. If I multiply it with anything, that's still a 0. If I multiply any multiple of this, if I add any multiple of this to that row, that's not going to help. Nothing I do is going to change the way this looks. This cannot be turned into an identity. So it's not so unexpected that 0 matrix doesn't have an inverse. Say inverse does not exist. Okay. So that wasn't so unexpected. But let's take another matrix. Suppose I take a matrix that is 1, 2, 3, 6. On the face of it, yeah, doesn't look like that's kind of a situation. But let's see. Again, we start our process by saying that we try to augment this thing. So let me just answer it here instead of going to another page. So here's 1, 0, 0, 1. We augmented this matrix, and I try to go about my business. What do? I try to get rid of this entry. Well, what is the command I use to get rid of this entry? -3 row 1 plus row 2 is my new row 2. I do this 1, 2, 1, 0. What do I get? 0 here, 0 here is -3 and 1. Our objective was to march toward identity. That is, I want to convert this into a 1. If I multiply, that doesn't help. There isn't anything else I could do. If I add a multiple of this row to this, like what could you think? You could think about, you could say, well, I want to create a 1 here. So let me add half of this row to this row. What is so bad about it? If you it's 1/2 of row 1 plus row 2 to create row 2, well, it's correct that this is going to become 1. But what's going to come of this one? It becomes 1/2. That is, that 0 you created is going to be messed up again. Is that right? There isn't anything you can do to fix the situation. As soon as you don't have the perfect echelon form, as soon as you have more zeros than you expected, and there is no interchange you could do to fix the situation here, if you can't force this pivot to be a non-zero number, the process is broken, it cannot be continued, and so you say the original matrix that I was given does not have an inverse. 1, 2, 3, 6 does not have inverse. Okay, the so-called space of matrices is has a layer of matrices inside of it, none of whom have inverse, and kind of not easy to tell from in advance that they wouldn't have an inverse. You have to go through this process. Okay, I guess we are going to talk about row equivalence on Friday, so let me stop the lecture here and just assign some exercises from this section. So from the inverse section on inverses, you have to try to do just as many of these things as it takes until you are comfortable with the process, but just to so the ones that I'm going to collect on Friday will be the following. You want to do 26. So this is from section 1-4. 26, 30, 32, 34. for some matrices, your life is going to be a lot easier than what we portrayed here. Some others, it's just not easy no matter what you do. So, okay. If anybody has any question about their homework or problems with it, you can come and yes.
Homework for 1-4 earlier, a couple of classes ago. You said you were going to take it up after the test. Are you going to take that up?
No, only these are the only ones that are going to be collected on Friday. Only these 4.